Welcome to chemistry class. We are in session 1 of the chapter D and F block elements. In this session, let me introduce you to the D block elements first. Then we shall also discuss about the electronic configuration of these D block elements. And then we shall discuss about some general characteristics of these D block elements. Let's understand what are these D block elements with the help of the animation of periodic table. We know that the elements in the periodic table are classified into 4 different blocks based on the entry of the differentiating electron into the particular sublevel. If the differentiating electron enters into S sublevel of the outermost energy level, we call them as S block elements. So even though helium is an S block element, but that is placed above P block because it resembles with the other noble gases. So in the case of S block elements, the differentiating electron enters into NS sublevel. In P block elements, the differentiating electron enters into the P sublevel of outermost energy level. Means the differentiating electron enters into NP sublevel. Whereas in the case of D block elements, the differentiating electron enters into the D sublevel of the penultimate shell, means the last but one shell. So in D block elements, the differentiating electron enters into N-1D sublevel. And in F block elements, the differentiating electron enters into the F sublevel of the anti-penultimate shell. That is, the differentiating electron enters into N-2F sublevel. So this is how the elements are classified into 4 different blocks based on the entry of the differentiating electron into the sublevel. So from the table it's very clear that the D block elements, they lie in between the S block and the P block elements. And this block consists of elements lying in between S block and P block from group number 3 to 12. So this is group number 3, this is 4 and so on. Or according to the old notation, we can also number them in this particular way. This is 3B, this is 4B, 5B, 6B, 7B. The group number 8, 9 and 10 together as the 8th one or the 8th B. And this is 1B and this is 2B. And these D block elements are also called as the transition elements. It is because the properties of these elements are intermediate between the properties of S block and P block elements. Means the D block elements represent change or transition in properties from the most electropositive S block elements and the most electronegative P block elements. Therefore, these elements are called as the transition elements. And the exact definition of transition elements is like this. A transition element may be defined as an element whose atom in the ground state or its ion in one of the most common oxidation states possess incompletely filled D sublevel. Means either in the elemental form or in its most common oxidation state, that particular element should possess incompletely filled D sublevel. Means there should be unpaired electrons in the N-1D sublevel. So definitely in any of these two forms, the number of electrons in the N-1D sublevel should be less than 10. Because of this particular reason only, the transition elements, they possess 2 incompletely filled shells. That is the outermost one as well as the penultimate shell. Even though we are saying that D block elements are also known as transition elements, but there are some exceptions for this. Here, the entire elements shown here, they come under the D block elements. Because in all these elements, the differentiating electron enters into N-1D sublevel. But only the elements from here to here, they are called as the transition elements. It means the zinc, cadmium, mercury and the element with atomic number 112, that is Barium, all these are not transition elements. What's the reason for this one? Because these elements, both in their elemental form as well as in their most common oxidation state, that is Zn2+, Cd2 plus, Hg2 plus, etc. They possess completely filled d sublevel. Means here it is 3d10, here it is 4d10, here it is 5d10, and here it is 6d10. As per the definition of transition elements, they should possess incompletely filled n-1d sublevel, either in the elemental form or in their most common oxidation state. But it is not the case with these four elements. So that is the reason why these four elements, they are not the transition elements, but they are considered only as the D block elements. But as they resemble in some of the properties with other transition elements, that is the reason they are studied together. And these four elements, we call them as the non-typical transition elements. So remember, zinc, cadmium and mercury, as well as the element with atomic number 112, they are not transition elements because their n-1d sublevel is completely filled with electrons. These transition elements are divided into four different series, and each horizontal row of D block contains 10 elements each. So this is the first transition series, this is the second transition series, the third one, this is the fourth transition series. And we know that in all these elements, the differentiating electron enters into n-1d sublevel. We call them as the D block elements. Here, the first transition series, this is present in the fourth period of the periodic table. And the second transition series is a part of the fifth period. And this one, the sixth period. And this is a part of the seventh period. So in the fourth period, the n value is equal to 4. And in the case of D block elements, the differentiating electrons should enter into n-1d sublevel. So that is the reason why in the elements present in this first transition series, the electrons are progressively filled in 3d sublevel. So we call these elements as the elements of 3d series. And in the case of fifth period, here the electron enters into n-1d sublevel, that is 4d sublevel. So these are the elements of 4d series, where the 4d orbitals are progressively filled. And here the electrons are filled in 5d sublevel. And here it is in 6d sublevel, which is a part of the seventh period. So these are the elements of 3d series, these are 4d series, this is 5d series, and this is 6d series. So 3d series is present in fourth period, which is the first transition series. And 4d series is present in the fifth period, and that is the second transition series, and so on. In the 3d series, it starts with atomic number 21, that is scandium, and ends with zinc, whose atomic number is 30. And the 4d series, that starts with yttrium, whose atomic number is 39, and ends with cadmium, whose atomic number is 48. Then in 5d series, the starting element is lanthanum, whose atomic number is 57. But here, the 14 elements coming after lanthanum, they come under F block elements. So that is the reason why the immediate 14 elements from atomic number 58 to atomic number 71, they are present below the periodic table separately as F block elements. That is, they are the lanthanides. So that is the reason why here we get the next element after lanthanides, that is hafnium, whose atomic number is 72. And the series ends with mercury, whose atomic number is 80. Then in the 6d series, the starting element is actinum, whose atomic number is 89. And again the 14 elements coming after actinum, that is from atomic number 103, they are the F block elements, that is actinides, present below the periodic table. So that is the reason why the next element after actinides, that is rutherfordium, whose atomic number 104, comes here. And this particular series ends with an element with atomic number 112, for which we write the symbol as UUB, un-un-bium. So that is how the D block elements are classified into four different series: 3D series, 4D series, 5D series, and 6D series, based on the specific D sublevel into which the differentiating electron is entering.